Girls, I'm going to read a book to you today called What Makes a Magnet? Let's go fishing with a magnet. Put different things in a box, a twig and some tacks, a needle, paper clips and rubber bands, bits of paper and aluminum foil, a pin or two. What else? You decide. Choose things that are small and light. Next, find a magnet. They come in different shapes and sizes. Tie one end of a string around your magnet. Tie the other end to a stick or a pencil. This is your fishing pole. Go fishing in the box. Put the things you catch in a pile. The others will stay in the box. Maybe you caught the tacks, paper clips, needle, and pins, but not the rubber bands and aluminum foil. There is a reason why only some things stick to the magnet. They have to be made of the right stuff. The material they are made of has to be magnet sticky or ferromagnetic. Anything you lifted out of the box probably has iron in it. The iron in these different objects is ferromagnetic. Iron is not only the only ferromagnetic material, but it is the most common. Can you tell which objects in your fishing expedition probably do not have ferromagnetic material in them? Need a hint? Look at what's still in your box. The wood in a twig won't stick to a magnet. Wood is not ferromagnetic. The rubber in the rubber bands won't stick to a magnet. Rubber is not ferromagnetic. What about paper? Aluminum? Nope, they are not ferromagnetic either. There's something else about ferromagnetic materials. They can help you make a magnet. Want to try? Start with a sewing needle. Make sure it can stick to the magnet. Place it on a table. Hold it there with your finger on the needle's eye. Rub one end of the magnet along the needle, moving the magnet from the eye of the needle to the point, not back and forth. Do this about 30 times. Touch the needle tip to a tack, paper clip, or pin. If the object sticks to the needle, you have a new magnet. The magnetized needle might even be strong enough to pick up a few objects. The stronger a magnet is, the more it can pick up at once. Which do you think is stronger, your fishing magnet or the needle magnet? Try testing them to find out. No matter which magnet is stronger, both magnets are small. They fit in your hand, but there are very large magnets too. In fact, the whole world is a magnet, even though it doesn't look like one. You can't see the Earth's magnetism, but you can make something that shows you it is there, a compass. Here's what to do. Make sure your needle magnet still works. Then get 2 small pieces of foam, plastic or cork. Carefully stick a piece on each end of your needle magnet. Float the magnetized needle in a bowl of water. The needle will swing around so one end points north, the other end south. Keep the needle in the center of the bowl so it can swing freely. Turn the needle around. When you let it go, the ends will point the same way as before. This happens because the needle magnet reacts to the Earth's magnetism. To finish your compass, put a dot of ink on the north end of the needle. The ends of the needle magnet point in different directions because they are different from each other. Each end reacts to the Earth magnet in its own way. One end reacts by moving and facing north. It is called the magnet's north-seeking pole, or simply its north pole. The other end moves and points in the opposite direction, south. This is the south-seeking end is the magnet's south pole. Magnets are strongest at their poles. When you picked things out of your fishing box, they stuck to the ends of the magnet, not the middle. Poles make magnets work. Magnets make compasses work, and compasses help people find their way around the block or around the world. Before compasses, people got lost a lot. How were compasses invented? No one knows the whole story. For sure, it began a long, long time ago. In ancient times, people from different parts of the world knew of an unusual stone. Iron stuck to it. It could be used to make new magnets from iron. And when the stone was used as a spinner, it came to rest with one end facing north and the other south. This natural magnet stone was important for making compasses. Some people called this magnet stone lodestone, which means leading stone or guide stone. You can see why. Nowadays, sailors, hikers, and pilots use different types of compasses to track where they are going. Compasses help explorers travel the world. They return home with new ideas, food, and art. So much happened because people were curious about magnets. Now it's your turn to explore some more. Can you use your magnet to push the needle magnet in the water without letting the two magnets touch? Try it. When the needle magnet moves away from the magnet in your hand, both magnets, north or south poles, face each other. Their similar poles push apart. Either way works, north facing north or south facing south. Similar poles always repel. Try making the needle magnet swim towards the other magnet. North and south poles pull towards each other. Unlike poles always attract. Does magnetism work through paper or cardboard? Test and find out. How far from a pen can you hold a magnet and still attract the pen? Try it and see. What else do you want to try? You could try making a magnet from a penny or a wooden toothpick, but that won't work. Remember, some metals are not ferromagnetic, and neither is wood. Only ferromagnetic materials can be magnetized. This is because of something too tiny to see. Picture the smallest bits of iron in your needle. They are like tiny magnets. Usually they point in different directions. When you stroke a magnet along a needle, the iron bits line up. The magnetism of one particle is added to another. Before making the magnetism stronger. That explains what happens when you make a magnet. But lodestone is a natural magnet. Nobody made it. What can make a natural magnet? Lightning. A bolt of lightning has magnetism. Lodestone has a lot of iron in it. A lightning strike on the right iron-filled rock can act like lots and lots of magnet strokes all at once. Scientists are pretty sure that lightning struck the places where lodestone is found and charged ordinary stone into magnetic stone. Now you know a lot of what scientists know about magnetism. Even so, sometimes it still seems magical. After all, it goes through air and water, glass and plastic, walls and tabletops. Enjoy this feeling of wonder. Keep exploring with your magnets like a scientist and see what else you can find out. I hope you enjoyed our book today, and when we get back to the classroom, we will have to explore more about magnets. See you later.